Hello and welcome to Mathematics with Simon. I'm Simon. Maxime Alec, my friend from France, was very kind about the Zeno's paradox video and also pointed out rightly that I haven't really demonstrated that a half plus a quarter plus an eighth plus a 16th plus a 32nd adds up to 1. And this video is attempting to right that wrong. So let's have a look at this. We're going to start here. We're going to imagine x equals 0.333333333 forever. And we're going to work out what x is. So we're going to work out what this decimal is. Now the point of this will become clear later. So if x is this, then 10 times x is going to equal 3.33 recurring, because basically to multiply by 10 you just move the decimal point. So we're going to move the decimal point one place to the right. 10x is 3.333. Now here's the trick. We take 1x away from 10x, and so all of the 3's, the infinitely recurring 3's, all disappear, and we just get left with 3. So 10x minus x is 9 lots of x. 3.3 recurring minus 0.3 recurring is just 3. 9x equals 3. Divide both sides by 9. X equals 3 over 9. X equals 1/3. I love that. It's really beautiful. Now this is stranger and stranger. Stranger things. X equals 0.99999 recurring. That means 10 times x equals 9.999 recurring. So let's take x away from 10 times x. We get 9 times x, and then we get 9 minus 0 is just 9, and then all the 0.9 recurrings cancel. So we just get 9 times x equals 9. X equals 1. So we started off as x equals 0.9 recurring, but actually x is the same as 1, which is a really fascinating result. The point is, when you take enough of these 9's, you can get arbitrarily close to 1. So actually this is a limit, and in the limit it is 1, which is fascinating. I mean, another way of looking at it is 0.9 recurring is just 0.3 recurring times 3, and we know that 0.3 recurring is 1/3, so if we times that by 3 we get 0.9 recurring is 1. Okay, so the point of all of this is now, in a similar way, we can say x equals a half plus a quarter plus an eighth plus a 16th plus a 32nd. And that means that 2 times x is double all of this. So if you double a half, you get 1. If you double a quarter, you get a half. If you double an eighth, you get a quarter. If you double a 16th, you get an eighth. So x equals this lot. 2x equals this lot. And now what we're going to do is we're going to take x away from 2x. So if we take the top thing away from the bottom thing, we get 1, but then the halves cancel, the quarters cancel, the eighths cancel, it all cancels. So all we get is 2x minus x is x, and then on the right hand side, all we've got left with is 1, so x equals 1. That is the proof, and that is a decent proof. Now, for Maxime Alec and all the other smart people out there, I've got 2 questions. The first question is, what's the connection between this reasoning and this reasoning? And no, the answer is not. They're both in the same video. The answer is, what links them? How are they connected? They are connected. It's obviously a similar sort of kind of thinking. And the second point is, can you punch a hole in my logic? There's a small hole you can punch. So this reasoning sort of works at GCSE. But at A-level or degree level, you might disagree with the way my reasoning works, although it's fundamentally sound. There's one slight assumption I've taken, so I'd love to get thoughts from that in the comments, or make your own video. I hope you've enjoyed this. Of course, please subscribe or hit the notification bell. I'd love to hear your ideas, and most of all, I hope you enjoy your mathematics.